Coordinate geometry, perpendicular lines. The red and blue line here form a right angle right there, meaning that they are perpendicular to each other. The mathematical symbol for perpendicular lines is this. That represents the word perpendicular. The gradient of the red line is equal to 1, and the gradient of the blue line is equal to -1. In this example, once again the red and blue lines form a 90-degree angle with each other, so they are perpendicular. The gradient of the red line is 2, and the gradient of the blue line is -1/2. Again, in this example, our lines are perpendicular. The red line has a gradient of 3, and the blue line has a gradient of -1/3. Now, you might notice a slight pattern here. The gradient for this one was 2, for this one was -1/2, so the signs are opposite. And if you take 2 and work out its reciprocal, so if you do 1 divided by this gradient, you get this one, and you also change the sign in the process. For this example here, starting with 3, if you change the sign, so that's positive, you get a negative value. If you take the reciprocal of 3, you get 1/3. So the gradients of lines which are perpendicular, like this, are related. So if you start off with one line that has a gradient of m, then the line that's perpendicular will have a gradient. So you change the sign, and then you do 1/m. So for instance, you start off with a line that has a gradient of 3. So you take its reciprocal for the perpendicular line, and you change the sign. If you start off with a line that has a gradient of 1/2, you take the reciprocal, so 1/2. If you flip that over, you get 2/1. 2/1 is just 2. That's positive, so this has to be negative. Let's say if this one was -2/3, a line that's perpendicular to a line that has this gradient, that has a negative gradient, this will be positive. You flip over the fraction, so the perpendicular line will have this gradient. And if two lines are perpendicular, if you multiply their gradients, so let's say the gradient of the first line is m1 and the gradient of the second line is m2, if they are perpendicular, this will always give you -1. This is a little proof to show that two lines are perpendicular. Just multiply their gradients. If you get -1, they are perpendicular. If you get something else, they are not perpendicular. For horizontal and vertical lines, and we know that horizontal and vertical lines are also perpendicular, do not use the previous methods. The way to tell if two lines like this are perpendicular is if you have equations that are given to you in this form. So if you're given the equations of two lines, one says x is equal to something and the other one says y is equal to something, then you know you're looking at these vertical and horizontal lines, so they will be perpendicular. Working out the perpendicular bisector. We have 2 points, A and B. The midpoint of the line segment that joins A and B is here. And the coordinates for the midpoint, so if you take the x coordinates 6 and 2, add them together to give you 8, divide that by 2 gives you 4, which is verified. from here. And the y coordinates do the same again. Add the y coordinates together, 2 and 4, that gives you 6. Divide that by 2, that gives you 3. And that's verified by y equals 3 here. What we're looking for is the equation of this line here, the equation of the perpendicular bisector of AB. To write down the equation of this line here, all we need are two things. Coordinates for one point that the line goes through, so that's the midpoint, we already have that, and the gradient of the line. Now we don't have the gradient of the line, but we know it's perpendicular to the line AB. So if we work out the gradient of the line AB, we can use that to easily work out the gradient of this perpendicular line. So the gradient of the line AB, so the change in y, so if I start with point B, the y coordinate there is 4, the y coordinate here is 2, so change in y, so we're subtracting, divided by the change in x, so the x coordinate again for point B, that's what we're starting from, is 6, minus the x coordinate here, 2. So 4 minus 2 gives you 2, 6 minus 2 gives you 4, simplifying that is a half. That's the gradient of this line. So the gradient of this line, the perpendicular bisector, is the reciprocal of this, and we change the sign. So the reciprocal of 1 over 2 will be 2 over 1. And 2 divided by 1 is just 2. We must change the sign. This is positive, so this will be negative. So the gradient here is minus 2. So we need to write down the equation of a line that goes through the point 4, 3, the midpoint 4, 3, and it has a gradient of minus 2. So using the form y minus y1 is equal to m brackets x minus x1, and the reason for using this and not y equals mx plus c is because we do not have the y-intercept. If you want to use this, you need to know what the y-intercept is. We don't have that, so I'm going to use this form. So y minus the y-coordinate, which is 3, is equal to the gradient, brackets, x minus the x-coordinate. And then simplifying this, on this side we've got minus 2x. Minus 2 times minus 4 gives positive 8. This is the y minus 3, taking the 3 over, so y is equal to minus 2x plus 11. This is the equation of the, and remember this symbol? Perpendicular, equation of the perpendicular bisector.